Let's have a look at the conclusion when we're doing a two independent group experiment. So in our conclusion, we need these things. We need to be able to answer our question. We need to be able to justify it. We need to describe it in context, but we've got to be quite specific about who they reply to. So that's, remember, thinking about who are our participants. Now, when we've got the results of this, our results are going to apply to those participants. It may or may not apply to anyone else, but when we write up our conclusion, that's what we're saying, is these results apply to these people because they are the ones we tested. And then we can look at improvements or other investigations that we might lead to. So when we come to answering our investigation question, the key idea is we've got to think about what results could we have got just by random chance. So because we randomly allocated and we put half of them in one group and half of them in another group, could the results have just been due to be us randomly putting people in those two different groups? Or do the results actually tend to be higher for one of those groups? So I just want to go through this little exercise with you to try and lead you to understanding what we do to decide this. So when I look at a box plot, think about your lower quartile. So your lower quartile is this point right there. And if I colour in all the data that lies above it, so all of that part of the graph, that will be 75% of the data being above that point. Okay, so that's the answer to that question. It's 75%. What percentage of data lies above the median? So then think, there's my median. What percentage lies above it? And your median, you've always got 50% above, 50% below. Okay, so 50% lie above the median. And what percentage lie below the upper quartile? So here's my upper quartile. And if I look at how much data there is below that, that is 75% of my data. Okay. So I want you to look at these two groups, and for my control group, we want to shade in the data below the median. So I'm going to find my median, and I'm going to shade in everything below that. Then for the treatment group, I'm going to shade in everything above the lower quartile. So there's my lower quartile. I'm going to shade in everything above it. So hoping what you notice is that 75% of the data in this group is bigger than 50% of the data in that group. There's actually a bit of a space between these two, okay? And that tells me I've got enough evidence to say that that one group tends to be bigger than the other. So that's what I'm looking for, is I'm looking for whether or not those overlap. Okay, and if I don't have overlaps, then I can say the results do tend to be higher for one of the groups. So let's have a look at an example there. So in this particular one, we've shaded in grey, we've shaded in here 50%. So there's my median, and I've shaded in 50% below it. Then for my other group, I've taken the lower quartile and shaded in 75% above it. And I can notice there that there's a space where they overlap. Okay, so there's a space where they both covered that same area. So that means I cannot say that there is any effect. All right, I don't have enough evidence to say one group tends to be bigger than another. Whereas if I look at now the graph underneath, I'm going to take my lowest median and shade in 50% below that. And then the bigger group, I'm going to take my lower quartile and shade in 75% of that. And I can see there that there is a space in here between them where there's no overlap. All right, so because there is no overlap, I'm going to suggest that there is an effect occurring. So in order to be able to conclude that there is an effect, I need to first of all have a well-designed experiment. And so that's when we've done our randomly allocating patients and participants into groups, and that controlling whatever we can. Then the other condition is that we need is this 75%, 50% that we've just looked at. And those things together mean that I can say that doing this tends to have an effect. There might be an effect. So let's look at our writing times. So we've got our writing times, and I want to find the median of the lowest group. So there's my lowest group, my lowest median, and I'm going to shade in 50% below that. Then I'm going to take the lower quartile of the other group, and I'm going to shade in 75% above that. Okay, so that's 75%, and this is 50%. Now I can see that there is a gap between them. Excuse me. So that tells me that I have got evidence. I can say that students who wrote with their non-dominant hand tend to take longer to write than those who wrote with their dominant hand. And the evidence for that is more than 75% of the writing times for my non-dominant is larger than 50% than all of the writing times for my dominant. So that leads me to suggesting that writing with your dominant hand does have an effect on the time it takes to write that passage for, and remember these, I'm being very specific about who my participants are, for the students in MAS2 at OSC in 2018. So I can say that because I randomly allocated, and because I've done that random allocation and I've controlled conditions, I've got a reasonably well-designed experiment here. So that's why I'm able to make that claim. So in terms of improvements, I could improve that by, if I got every student to write the paragraph 5 times, then I could find the average of those, and that would give me a much better estimate of how long it takes somebody to actually write it. Okay? So that's one improvement I could make. And there's lots of other things that we can think about as well. Limitations. Well, I only did this using students at OSC. And in fact, I only did it to students that were in Maths 2 in 2018. So that means my results apply to those students. I can't assume that it applies to any other students, particularly ones that are younger than 16 or over the age of 18, because I didn't have students of those ages in my classes. So if I wanted to show that younger students can also write faster with their dominant hand, then I would need to do that whole experiment again with younger students. Okay? Other suggestions for other investigations? I can make a small change. So for example, I could use a different passage of text, or I could have something written in a different language. So I could change the experiment around a little bit.